So today we'll be finishing up part 2 of percents. So this is Friday, May 22nd's lecture. This is a little bit of a longer lecture, I have a feeling. I have a lot more example problems. I'm trying to minimize my writing, but that's really the best way I can show you this. So this sometimes can get a little hairy, especially towards the end, but hopefully we'll just take it a piece at a time. And if we need to have a tutor session next week, like on Tuesday or something after Memorial Day, we sure can. Alright, so when we're looking at percent change, we're looking at how much something, we need to calculate the obviously how much has changed. Okay, so we're looking at the amount of change over the original number, and that will equal then your fraction of change. Okay, so it's just again like, where do you put all the numbers and how do you set up the problem? I think that's probably the most complicated part for everybody. I gave you a rather lengthy homework assignment. It is a combination of some problems that I have found elsewhere and then problems from your textbook. So, alright, so for example here we're looking at if a patient weighs 200 pounds and during his hospital stay he lost 40 pounds, what percent change of body weight did he lose? So what percent change of body weight was lost? Okay, so we're putting again the amount of change, which is 40, over the original number of 200. Okay, so then you compare that to the the proportions that we've done, the ratios, and so you would kind of work that more across, where you'd have the 400 over the 200, the x over the 100, you'd cross multiply, and then you would get your 20% change. The other really quick and dirty way to do it, I guess, would be to calculate, try to get this to 100. Okay, so we would try to go ahead and we'd have, hold on, let me see if so we would have basically 40 over 200, and that's pretty much what you're doing for this particular problem. That's a weird draw. And if I were to cut these both in half, okay, then I would have 20 over 100, was, we should know, is the same as 20%. Okay, but they're basically showing you here the cross multiplication of 40 times 100. So this numerator times this denominator, which is going to give you 4,000, and you're going to divide it by the denominator, which is 200, divide by 200, which is going to give you then 20% change. So, however, I guess if you have a problem like that, however you get to the answer, but that's kind of what we've been building up to, all these fractions and ratios and stuff. So this again can be represented by either an increase or a decrease. A percent change can. It's not always one way or the other. So you have to again read your problem carefully and see if it makes sense. I noticed that in some homework things that I was grading today, that people, you're comparing these ratios, the proportion, equal proportion, and you're reducing something, but then for some reason you're having a larger number, which doesn't make sense. So just kind of look at the big picture for a minute. All right, so we might want to look at percent change for various things, as far as medical reasons, doses and weight, other things, fees, income, and other percent changes. And this here, this amount of change over the original number, this, I'm trying to write this as like a fraction here. Unfortunately, the way it's set up on the PowerPoints, it's hard to just do a line without this bullet again. So this is what this is. Amount of change over the original number equals your fraction of change, which I just said on the previous slide too. Alright, I was just going to look really quick to see if I have a reference. Yeah, this is actually on page 179 also in your text, so if that helps. Alright, so you have steps to this problem. The first is set up the fraction of change, and then you're going to use the proportion to set up a percent conversion. Because remember that percent always means over 100 or out of 100. Alright, so here is an example. This is from page 179. So you have a 12-year-old WO, you'll see a lot of times abbreviated in the hospital and medicine, year-old, 12-year-old boy, weighs 180 pounds. He needs to weigh 120 pounds. So he's lost 60 pounds in the past year to achieve his goal. What then is the percent of change of that amount of weight that he lost? Okay, so what we're going to look at here is we're going to do the step 1, which is set up the fraction of change. So he lost, or we also had that on the amount of change. Okay, so this is the amount of change, is the 60. Okay, so amount of change over original number. So we're going to have 60 then, and our original number should be 180. So we have 60 over 180, and we're going to equal that then to what over 100, because we're trying to find that value, that percent, which is the number over 100. So we're looking for the percent. And remember, before the is and of and all that stuff, if it's over 100, then it's your percent. So that's what we're looking for. So we would go ahead and we cross multiply, so we'd have 6,000, because we'd do 100 times 60. Okay, so we'd have 6,000 would be in the house, for people that like to have that little analogy. My 6 isn't looking so good. I'm having trouble today with my mouse. Okay, so that's a 6,000, then divided by 180 rather, sorry. 180. I was almost going to say 18. Yeah, I was wishing someone had to write another number. Okay, so 6,000 divided by 180. So if we do that, if you hear any growling in the background, it's my crazy puppy. He is 6 months old. He's a little bit rambunctious right now. Alright, I'm sorry. Alright, so 6,000, what this is supposed to be. So when we do the math, we do 6,000 but divide by 180, we should get 33.33% weight loss is what he experienced. He experienced a 33.33% weight loss. Okay. Make sure you're reading your problems carefully too. I probably had 4 or 5 people this last assignments that I graded that wrote down that they were doing a certain page number, but they ended up doing problems on the wrong page. So really double check your work. Pay attention to those details. Make sure that you're doing the right problems, because then I'm just grading you down and then you have to resubmit your work. So always look to see what the directions are, if you're supposed to leave it as a fraction or reduce it or whatever you're supposed to do. Okay, I can't stress that enough. You know, be careful, because details are important. All right, so here we have an example of this problem. So this one is basically a money problem. It's saying it's called a single trade discount. So we're trying to figure out the net price of a surgical instrument that originally is listed for $189.90, and it has a discount of 40%. Okay, so the percentage is made into a decimal by moving the decimal places to the left. So you're basically changing 40% to a decimal is what it's asking you to do. Okay, so we're going to change 40% then to 0.4. Okay, so this is like one of those two-step problems. So the first part is you're figuring out 40% of $189.90. So you're going to go ahead and do the math for that, and that gives you $75.96. Okay, but this is kind of similar to that one problem that had the insurance, how much the insurance covered, and then what did the patient have left to pay. So this is only the first step. Now you need to figure out the difference. Okay, so now you're looking at this to subtract the amount of the discount, basically the answer from that first step, and that's going to give you your net price. Okay, so make sure you're following through with every step. All right, now we're looking at percent strength solutions. So for example, and this is I think the part that starts to get a little bit on the hairier side. Okay, so percent strength of different solutions. So that refers to how much of a substance then has been dissolved in a specific amount of liquid. And I'm actually going to define that a little bit better here in just a second. So we have 15% of a drug, okay, 15%. So a percent like that always means grams over mil, okay? So we'll go into this a lot more detail as we start doing drug calculations. So 15% of a drug is the same as 100 grams of drug to 100 mils. Okay, so 100 gram of drugs to 100 mils of solution. Okay, it's always grams to mils, and it's grams over 100 mils. So that would be the same then as 15 over 100. Okay, so 15 over 100. And then if we were to reduce that, we're dividing both sides then by 5, or the top and the bottom rather, by 5, which then reduces to 3 over 20. Okay, so if it says to reduce, then you need to do that. All right, but I want to clear up some terminology here. So because you're going to see solute, solvent, and solution. Okay, so a solute, and I kind of like draw a little picture out. A solute is your grams, okay? So here's your grams, okay? And your solute is like your little bit of, like maybe your powder or your little bit of granules or whatever little things that you're going to mix into it. So your grams plus your mils, okay? So your solvent then is in mils. So it's what you're going to mix your solute with. So like this would be like a cylinder or something. Oh my gosh. Okay. So this would be, sorry, my dogs are being a real pain right now. So that is your cylinder, what your your solvent, whatever you're going to mix it, the solute with. Okay, so then that's going to give you your solution. Okay, so that's going to be your solution in the end. So you're basically adding these two, and then it's going to equal your solution. Okay, and then that is in your grams per mil. Okay. So I'm not going to try to write out the word solution because I know it's going to take me forever. So your solute plus your solvent equals your solution. So your solute, think of it being what needs to be added, your solvent, what you're adding it to, and then your solution is the mix, is the liquid that has the medication or the other substance mixed in with it. Okay, mixed in with the solvent. So that's where your grams then per mil come out. Okay, all right, hopefully that's making sense. Okay, so moving on. I just have lots of different notes. So this is kind of on page 181, kind of to help you if you're trying to follow along with your text, which I think definitely helps, especially, well, they actually have the picture here, and that's probably where I got the idea from, was on page 181 when I did this lecture the first time. But especially since we can't be together and discuss this one-on-one, your text is your best resource. All right, so again, looking at the proportion to convert to solution. So this is definitely helpful when we are converting to smaller or larger amounts of solution, because we're not always going to need 100 mils of a solution. So we need to make sure that we have the correct ratio of pure drug to solution. Alright, so here's an example. So we have we're trying to solve for an unknown, so we need to set it up as a proportion. Okay, so that's pretty much how you're going to be doing a lot of these problems. So you have a drug is an 8% strength. Okay, if the doctor is ordering 25 mils of that solution, how many grams of the drug is the patient getting? Okay, so we're looking at 8 grams to 100 mils because you're doing the 8 grams. Remember, 8% then is 8 grams to 100 mils. Okay, so 8 over 100 is equal to what? How many grams to 25 mils? Okay, so this should tell me right here as I'm looking at it. So I'm looking at comparing 8 grams to 100 mils, and then I want to know how many grams am I going to need in 25 mils. So this number here should be less than 8. Okay, so again, we set this up. I'm going to try to draw it. I'm sorry. I wish I had a better way. I tell you, I liked it when I had that little surface probe. It took forever to convert. Okay, so we have this, and we're solving for x over 25. And again, this is another mistake that I saw. Making sure you're setting them up properly, that you have your units across from each other. Okay, so if people had errors on this last homework, it's because they didn't have, they had things flip-flopped around. Alright, so I'm trying to find grams. Okay, so this is where I'm going to do my cross multiplication. 25 times 8 equals 200, and then I'm going to divide it by 100. Okay, my dog's going to start barking again, I know it. So 200 divided by 100 then equals 2 grams. So that makes sense, right? So I have 8 grams to 100 mils is the same as what 2 grams would be to 25 mils. Okay, I hope you're hanging on here. Okay, so now we're moving on to page 183. And this is actually a problem that is in several different steps. Okay, so this is on practice 9, page 183. So we have 10 grams of a drug are in 25 mils. What is the percent strength of this med? So this should tell you right now you are trying to solve for your x is what the percent. Okay, what is the percent strength? So you're trying to solve for the number over 100. You don't know the percent. Okay, so that's what you're trying to solve for. Okay, and I don't know why I like to kind of set them up this way. Okay. Okay, so I'm trying to, so I've got 10 grams, it's telling me this is what I have. So I know this, I have 10 grams over 25 mils. Alright, so that's how I figured this one out. Okay, that's how I solved this one. So I'm going to go ahead, I'm looking for x, I'm looking for the percent. X is my percent. So I'm going to do my cross multiplication. I'm going to take 100 times 10. That's just going to give me 1,000. And I'm going to take 1,000 and divide it by 25. Okay. So that should give me 40%. Alright, sorry about that. Okay, so we figured this out, and I said it was 40%. Sorry, my daughter just came home, so I had to get the door. 40%. Everybody wants the mother when I'm trying to focus on something. It never fails. Alright, so all you moms out there, I know you sympathize. Alright, so what this is saying is the strength of this medication of 10 grams and 100 mils then is 40% is the strength of this medicine. Okay? Alright, so that is one of our examples on page, I'm just trying to look. Oh, I know, this is the one that we want to change again. So this is the example that's in the example box. Alright, moving on. So now we're looking again at that same page, but we're further down on the page, practice 9. I'm sorry. That first problem that we just finished, that was actually in your little text box under example. Alright, now we're moving on to practice 9, where this has several different steps. So the doc has ordered a 15% saline. How many grams of pure drug will be needed to make 25 mils solution at 15% strength? Okay, so we should know that the 15 grams over 100, so that's what the 15% means. So that's our known part. I guess I usually put the known on my left and my unknown on my right. Oh my gosh. So we got 15 over 100. So that's my known. And I'm trying to figure out. So again, the units are going to help me out. So this is grams, right? And this is mils. And the problem is telling me it knows mils. So the 25 then is the mils. Okay, that's where that goes in part of the problem. The 25, gosh darn it, is the mils. Okay. Alright, so we're trying to solve then for x. Our x is the grams. So it's asking me how many grams. So that's where we just really have to pay attention to those details and what it's asking. Okay, I'm sorry that's so sloppy. But that is basically how we're setting up that problem. So we have 15 grams over 100 equals how many grams over 25. Okay, so again, if I look at this and think about it, 25 is a quarter of 100. Okay, so when we're comparing 25 mils to 100 mils, our number for the x should be smaller than 15. Okay, so when we do the math, we multiply 25 by 15, we get 375, and then when we divide it by 100, this is why all this decimal stuff is important too, you get 3.75 grams is your answer. So 3.75 grams is your answer. Let's do GM now. Alright, okay, or G, however you want to do it. Want to do G, do G. Okay, alright, so hopefully that helps some. Now this problem is a little bit tricky. I used to actually assign this one, but I want to go over it here a little bit more. So now it's the same problem basically. We have the 15% saline. How many grams of pure drug will be needed to make 35 mils at 15% strength? So we're going to basically set this up the same way. We're going to do 15 grams over 100 and what we're trying to solve for again is asking me how many grams, so that's my x over 35. So this is more, a little bit more than 25. I do my math after I've
multiplied 35 by 15, I get 525. I divide it by 100, and so my answer is 5.25 grams. Okay, and that makes sense. It's less than 15 because 35 is less than 100. All right, we'll do one more part of this problem. Same problem, but this time we want to know how many grams of pure drug is going to be needed to make 125 mils. Okay, so we have, again, our 15 is over our 100. That's representing our 15%. 15 grams over 100. Let's see if I can do my little g, or a big G. Okay, so we have over 100. And now we are comparing this proportion to 125 mils. So we got 125 mils. So that should tell me my x that I'm trying to solve for is going to be greater than 15 this time. Okay, because I'm comparing it. This is my x. I'm comparing 15 grams to 100 mils is the same as how many grams to 125 mils. Okay, so I'm going to do the multiplication again. 125 times 15, that is going to give me 1875. I'm going to divide it by 100. I'm going to move 2 decimal places over to the from the right to the left. So I had 1875 when I did my multiplication. 2 decimal places over. 1, 2. So my answer is 18.75. Okay, 18.75 grams is my answer for this one, which is indeed more than 15. Okay. All right, hang in there. All right, now another problem. I gotta find my work on this problem. Oh, it's right here. Okay, so on this one, this is the next page, page 184, practice 10. So we're using like a percentage, a fraction with this percent. So what is that going to look like? Okay, so we have a 7.5% strength solution has been prepared. How many grams of medication are in a 7.5% solution? Okay, so how many grams would that be? Well, this one should be fairly easy. So it's going to be, we have 7, for Pete's sake. So we have 7 1/2. So I'm trying to write 7 1/2. Don't let it scare you that it has a percentage, or it has a fraction in it. It's still 7.5 over 100. Okay, so our answer is pretty simple, really. 7.5. Okay, 7.5 grams. Okay, so I just wanted to show you that that was the same. Okay, let me see what's next here. But our next step to this question then, how many mils of solution are in the 7.5% strength solution? How many mils of, that should say of a solution, I'll have to go back and fix that, of a solution are in 7.5% strength solution. So we have our 7.5. So this is basically, alright, so I have a little mistake here, trying to make this a half. Alright, so we're looking at grams over mils. Yes, 7.5%. So really it's just kind of breaking down that problem. Okay, so your mils then are 100. Okay, so it's just kind of like defining each part of the problem. This being your grams, so this was your first answer in the previous slide, and this is your answer on this slide, 100. Okay, so nothing too terribly tricky there. Just kind of defining each part of it. So now we want to express this, and this is where it gets kind of tricky, I think, for people. We want to express this as a simplified ratio. Okay, so a simplified ratio. So we have, again, 7.5. It's going to take me a while, guys. 7.5 over the 100. Okay, so this is the same numbers we've been working with, but now it's asking us to express this solution in a simplified ratio. Okay, so what can you tell me? What is 7.5? This is a mixed number. I want to change it to an improper fraction. Okay, so we should say 15 over 2, right? 15 over 2 is the same as 7.5. Now remember, as we are looking at this whole thing, this line here is basically telling me divided by. So I'm going to say 15 over 2 divided by 100. Right? So we should know kind of what that looks like. So 15 over 2 divided by 100. Remember, and then it's 100 over the 1. Okay, remember your top number is always to your left. Your top number is on your left. So that's going to be the same as 15 over 2. Keep that top number, that top fraction on your left, multiplied by 1 over 100. Because remember, when we divide with fractions, we flip the second one. Okay, so now we have 15 over 200. Okay, and then we ask ourselves, can that be reduced? Yes, ma'am, it can. We're going to divide both sides by 5. So this is going to be 3 over 40. How do we write that as a simplified ratio? Okay, we need to take this fraction and write it as a simplified ratio. Top number's on the left. So we got 3 to... Wow, that was really bad. Okay, there we go. There we go. A little large, but it'll do. So we got 3 to 40. Okay, wow, lots of writing. Okay, what do we got next here? So, how much of pure drug then is needed to create 3.5 mils of the solution? So again, we're still working with this problem, okay? And this is going to be the same as what we were doing previously. So now we know our percent. Remember, our percent was the 7.5 over the 100. That's what it told us. So this is like, you know, part 1, part 2, part 3, part 4 of this problem. Okay, grams, mils. So that's telling me where I need to put my 35. My 35, need 35.5 rather, sorry. My 35.5 needs to be on the bottom. Okay, so this is a tricky one. Okay, so now I'm going to take my fraction over here again, change it back to an improper fraction, and I'm just going to do the multiplication. So the 7.5 is going to turn into 15 over 2, and I'm going to multiply it by 35.5, which is the same as 35.5 over 1. Oops, this is a 5, not a 1. Thinking about the 1. So we got 35.5. So the 15 times 35.5, if you do your math, you should get 532.5. Can't write a dot to save my soul. Divide by 2. Okay, we're multiplying just straight across, remember. So I got 532.5 divided by 2, which is going to give me 266.25. But remember, I'm not done. All I did is do the cross multiplication here, and I got 266.25. That's just taking 15 over 2 times 35.1 over 1, and then reducing this. Now I have to take this amount and do what? Divide by 100, right? Divide this by 100. So I'm taking 2, try to do the best I can here. 266.25 divided by 100 means I'm making it smaller, moving 2 decimal places over to the left. So my answer should be 2.66 grams, or you can round it to 2.7 grams. Okay, all right, we made it. Okay, so lots of practice on this. There's lots of steps, so just make sure you haven't forgotten your steps. Think through it and see, does it make sense? Okay, so you're looking at 7.5 grams to 100 mils is the same as, again, I forgot to add this part right here. This is mils. It's the same as how many grams to 35.5 mils. It's going to be less than 7.5. It's 2.7. Okay? All right. Good luck.